Here we're going to graph a linear function when its equation is written in slope point form. Here we have a linear function that's written in slope point form, and we're going to use this slope point form equation to get our information to be able to plot this on the graph. We're going to compare this slope point form equation with the slope point form formula. So by comparing the actual equation with the slope point equation formula, we're going to determine our set of coordinates. So what we want is we want a point on the graph, so we need a set of coordinates, and we also need the slope in order to properly represent that graph. So we know a point is written x, y. So if we look to our equation above, we need to come up with our x coordinate. Now it gets a little bit tricky here. We see that it is a 2 and it looks like it's a positive 2. We have to remember that there's a negative here. So in order to meet this positive, we would have had to have a negative and a negative. So that means this 2 initially was a negative. So our x is actually negative 2. And if we look and compare, we can find the y, which is positive 5. And once again, comparing the two equations, we can see that our slope is going to be 1/3. So now we have one point and we have the slope of the line. So that's enough information to go ahead and graph. So the point we're going to mark is a -2, 5. So the -2 is on the x-axis and the positive 5 is the y. So where those -2 and positive 5 meet, it's right there. Now we look at our slope. We have a rise of 1 over a run of 3. So we go up 1 over 3, 1, 2, 3. Now we have 2 points. We can go ahead and connect them with a line. And we now have our slope point equation represented on the graph. So what we're going to do now is we're going to take a graph, and from that graph we're going to write the equation in both slope point form and slope intercept form. So we're going to start with slope point form. First thing we want to do is we want to identify the coordinates of one point. So I have a point here. What we want to do is just quickly identify what the coordinates are. So we can see here the 4 on the x-axis and the 2 on the y-axis. So our coordinates are 4, 2. Now we're going to determine the slope of this line, and to do that we're going to start at one of our points and we're going to calculate the rise over the run to our next point. So our rise is 1, 2, 3, 4, 5, and our run is 1, 2, 3, but we're decreasing. It's actually a negative. So we have a slope of -5/3 or 5 over 3. So by now we're familiar with the slope point form equation. Y minus y1 equals m times x minus x1. So now we're just going to simply substitute our y coordinate, which is 2, for our y1, and our x coordinate, which is 4, for our x1, and -5/3 we will substitute for m, representing slope. So the slope point form equation of this graph is y minus 2 equals our slope, which is negative 5/3 times x minus 4. And once again, you can just see our values that have been substituted. Here's our y from the graph, which was 2. Our x was 4. And our slope is negative 5/3. So moving on to slope-intercept form of this graph, we'll just quickly review the slope-intercept form, what the equation would look like. And it's a y equals mx plus b, where our m is the slope and our b represents our y-intercept. So we can determine the slope-intercept form of this equation using our previously calculated slope point form. What we want to do is we want to now isolate our y. So the first thing we want to do is remove the brackets that hold x minus 4. And the way we do that is we're going to multiply negative 5/3 times whatever's in the bracket here. So negative 5/3 times x is negative 5/3 x. And now negative 5/3 times negative 4, we can also view this as negative 4 over 1. So it's simply negative 5 times negative 4 is going to be positive 20. And negative 3 times negative 1 is positive 3. Next thing we're going to do is we're going to solve for y. So we have y equal, we're going to take our negative 2 and we're going to bring it over across our equal sign, and when a negative moves across the equal sign, changes into a positive, so now it's positive 2. To make things simpler, we're going to take our 2 and we're going to turn it into 6/3, just to make it easier to add the 20/3. So 6/3 is the exact same thing as 2, it's just written in a different way. So now we have y equals negative 5/3 x plus 26/3. And 26/3 cannot be broken down any simpler. Remembering back to our slope-intercept lessons, we know that 26/3 is the y-intercept, so that is where the line crosses the vertical line or the y-axis. And if we can look to the graph, 26/3 is not a nice whole number, and we can see here that our line crosses somewhere just under 9, and it's not really a nice whole number. It would be a decimal. We have a slope point form equation for this graph, and we have the slope intercept form equation for this graph.